Good morning, everyone, or afternoon, evening, night, you know the drill. The presentation I've prepared for you today is a brief overview of test-driven development. What this means, some common misconceptions, its history, and the pros and cons of adopting this methodology for software projects. So, what is test-driven development? The core aspect is that you write unit tests before writing the code itself. This takes the form of rapid cycles where test production code is written to pass those tests, then tests for the next segment of the program are written. There are two schools of thought on what the primary point of all of this is. The first is that if you're writing the tests in advance, then you can use those to match up with your requirements documentation. There's nothing stopping a team from having a test in place for every requirement in advance in order to be able to show project progress. This group of people see the test-driven development's aid primarily in its effects on the design and requirements process. The second view is that test-driven development helps programmers to write better code. Case studies have regularly shown that projects utilizing test-driven development have cleaner, simpler, and overall better architectural designs. And programmers are free to do what they think best, with the expectation that the tests will be there to verify that their ideas worked correctly. Additionally, writing the test before production code forces the developers to consider exactly what the method signatures should be and encourages a deeper understanding of the system to be created. Extreme programming, one of the Agile methodology subsets, utilizes test-driven development as a core component of its method. Many teams take the formalized method written by Kent Beck in his book Test-Driven Development by example. I'll describe his method in more detail shortly. This chart from Maya Kenning-Bolo's paper, A Case Study of Test-Driven Development, serves to illustrate the difference between test-driven development cycle and the traditional development cycle far better than I could explain it myself without aid. As you can see from the diagram, test-driven development relies on this cycle of write test, write passing code, write test, write passing code until the completion of development, while traditional methods usually have the majority of testing done at the end. It should be noted that many Agile-based methods don't necessarily test at the end of all development, but may instead write tests at the end of each sprint, release, or development cycle. The key difference here being that all of these still default to writing the tests after the applicable section of code is written, rather than before. Kent Beck's book, Test-Driven Development by Example, is considered one of the foremost references regarding test-driven development. His book breaks the development process into three core phases. The first is the red phase. In this phase of development, the developers write unit tests for the upcoming section of work. These tests should be written into a fail state, hence the name of the phase is red phase. If the test passes at this stage, then it should be rewritten until all tests are failing. The next phase is green. This phase is where production code is first written. The goal is to write code that causes all written unit tests to pass. Any solution that works is accepted here, even if it's not the best, cleanest, or most efficient way to solve the problem. When all unit tests are passing, then the next phase may begin. Refactor can be somewhat of a misnomer here. This phase is when code is reviewed. This is also the phase where more robust solutions can be implemented and the code can be made more efficient and brought more in line with good practice standards. Any architectural considerations that require reorganizing the code are also implemented at this stage. It's perfectly possible that when reviewing the code from green phase, there will be nothing that needs to be rewritten or refactored, but the code should still be looked at with an eye to improvement during this phase. After refactoring, the cycle begins anew with writing fail state tests for the next portion of the product to be worked on. From here, we can go back to the diagram on the previous slide and see how it matches up with this process. As you can see, the first three blocks in the test-driven development cycle would align with the red phase. Any tests that pass here go back to the writing stage, and when all tests are failing, we begin writing code. This midsection corresponds to the green phase, where code is written until it passes all the test cases. And once the requirement is met, We proceed to the refactor stage, which will then continue until the team is happy with the code and all tests are passing before the next development cycle begins. Test-driven development's history. So test-driven development is not a new thing by any means. It was first in common use back in the 1960s. Developers then would often have their expected outputs known before even creating the punch cards to be fed into the computers, in order that they could quickly check their program for accuracy. Computing was time-consuming enough that developers had limited face time, so to speak, with the computer itself and had to find ways to maximize their time efficiency when they had access. As computing became more accessible, the practice somewhat dried up for a few decades, only to re-emerge with the development of automated testing suites. The Smalltalk community's S-Unit testing framework is often attributed as the first modern usage of test-driven development. The key difference between the original and modern uses of test-driven development is that the original was a manual testing technique, while the modern version is an automated testing technique. Kent Beck, author of the aforementioned book and one of the members of the Smalltalk community, helped port this practice to Java by being one of the key developers of JUnit, along with Eric Gamma, David Saf, and Chris Vasudevan. Test-driven development became widespread amongst Java developers very quickly, as JUnit eased the way into automated test suites. Once the Java community had accepted the practice, it was only a short time before most other common programming languages had both a similar testing framework and teams utilizing test-driven development practices. Now, there are a few common misconceptions regarding test-driven development. The first that comes up most often is that test-driven development is too time-consuming. In reality, this statement applies just as easily any time that is spent on testing. And if you've worked in a corporate environment for a few years, it's fairly likely that you've encountered this at least once among your project managers. Many top companies have done in-house studies of the cost and benefits of test-driven development. Microsoft reported that pre-release defect density of the products decreased between 40% and 90%. This wasn't a comparison between testing and not testing, and I hope I don't have to convince anyone in this audience of the problems with taking the latter path, but between test-driven development and standard development cycles. We've seen it documented time and time again that defects, especially those caught late in the process, are one of the most significant time-delaying events during software development. Another common misconception is that all tests are written before any production code. If you recall the process diagram from a few screens back, then this is just not true. It's rather said that all tests are written for a given segment of the production code. The misconception also merges into the next one somewhat, that TDD teams will have nothing to demo to the stakeholders during development. While that could be the case if the previous misconception was the truth, in actuality, there's nothing stopping a team using test-driven development from demoing their work. In fact, since all tests are passing in each cycle, there's no reason they can't have a working demo after every development cycle in their product, if they would like. Now that some common misconceptions are out of the way, let's see what the actual downsides can be. The initial productivity drop. Yes, there should be an expected initial drop in team productivity for a team that is switching to use TDD for the first time. While something to consider, this isn't an issue specific to test-driven development. Anytime a team uses a new technology or technique, there should be an expected learning period as they get up to speed. It's also important that your entire team is on board and in agreement with using this technique. If you have some members of your team using test-driven development and some others not using it, then most of the benefits will be lost, and it's likely to cause additional friction among team members, since your expected pacing and methods can be dramatically different. Sometimes management can be hard to convince. Have you had to convince a project manager of the need to perform testing before releasing a product? Imagine doing that before you even have a product to release. In reality, TDD has been shown to increase overall developer productivity and save time on projects, but you'll need management that either understands that natively or is willing to let you throw numbers at them from case studies in order to make your point. As one article stated, software has no silver bullet, and test-driven development is not an exception to that. If a developer writes a bad test containing errors, then there will be no way to ensure that bad code does not get accepted through that test. TDD requires the developers to understand what they are creating and write the proper tests as well as possible in order to proceed with confidence. Test-driven development doesn't often apply to any legacy code bases. The entire method is based on the assumption that you are starting a new project from scratch, or at least introducing TDD early in a project's life. It may not be impossible to fit TDD into legacy code bases, but square peg, round hole. Now, I've already touched a little on some of these benefits, but here are a list of the benefits of taking a test-driven development approach to software development. First is the early detection of bugs and errors. The later in the software development lifecycle that bugs are caught, the more time-consuming and more expensive it often is to fix them. The test-heavy approach of TDD lends itself very well to catching bugs and errors at the earliest possible time in the development process. The already existing test cases provide very rapid feedback to programmers as they make changes to the code. Simply because if a previous passing test fails, then it's a sign that the programmer needs to review their work again. And if the test remains passing, then at least nothing was obviously broken. Projects utilizing test-driven development compare favorably to other methods when it comes to the number of defects found in the completed project. Case studies have shown these differences to have a wide range, but even on the lower end, test-driven development still comes out very far ahead. Improved productivity. While an initial productivity drop is to be expected as teams learn new methods and become used to using them, test-driven development shows a marked increase in developer productivity over the long term of a project's life. Now, these last 2 points are not as easily quantifiable, but based off several case studies and developer interviews, they seem to be fairly consistently repeated. It's been found that often test-driven development results in simpler and cleaner code, including less complex architectural designs, and that developers working in test-driven environments show an increased level of confidence as they proceed with their work. So, in summary, test-driven development is a cycle of writing unit tests before each section of production code. Again, not all tests before any code at all, tests before each section of code. Test-driven development has been shown to increase productivity and reduce post-release defect rates significantly. It was most commonly formalized by Kent Beck in test-driven development by example, with the green, red, and refactor phases. And it has been shown to improve code cleanliness and developer confidence. Here's a list of some of the references I went through in creating this presentation. The primary reference was by Maya Kinigbolo in a case study of test-driven development. And some of these others just gave me some more background information on the history of test-driven development and how it is used today. If you have any questions, feel free to reach out to me and ask. And I hope you all have a great day.